All right, so let's see. So we're going to help find some formulas. We're going to place specifics, right? The equation of the line, tangent line to the curve when z equals 8. So you should go through limit as h goes to 0, blah, 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 blah. Or you could use the other one if you want to try that. You should figure out that the value of the derivative, which I'm going to call h prime of 8, you should figure out is 1/4, assuming I did it correctly. You also need to know what h of 8 is. And 8 minus 4 is 4. Square root of 4 is 2. So your tangent line, I'm going to start you crazy. So a lot of you will think y minus 2. I'm going to say y equals 2 plus 1/4 x minus 8. So this is the same thing as saying this. It's just a slightly different form. So add the 2 to both sides. And you get that. That's going to set us up for later. This is what's called a first-degree Taylor polynomial, which we're going to talk about later in the course. But it's also the tangent line. Now let's see. For g of x, determine the derivative at 1. And then for h of x, determine the derivative at 3. So to figure out if we have a derivative, your first step is to plug in the value. So the limit as x goes to 1 from the left of g of x is 8 minus 3, which is 5. The limit as x goes to 1 from the right is 4 plus 5, which is 9. So not continuous. Therefore, that's 3 dots mean therefore, not differentiable. So we don't have to do that problem any further. You cannot find the derivative. The next one, limit as h goes to 3 from the left. Try again. Limit as x goes to 3 from the left of h of x. So 9 minus 12 is negative 3 plus 8 is 5. Limit as x goes to 3 from the right of h of x is 2 times 3 is 6 minus 1 is 5. Okay, so now we can find the derivative. Now I want you to go through and figure out the derivative of x squared minus 4x plus 8 using the definition of the derivative, and 2x minus 1 using the definition of the derivative. So set it up, limit as h goes to 0, blah, 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 blah. Feel free to plug in 3 for x, so you don't have to do it in general, x plus h. You can do it with a 3. But you should figure out that the limit as x goes to 3 from the left for h prime is 2, and the limit as x not h, goes to 3 from the right of h prime is also 2. So we are differentiable. We have h prime of 2. No, h prime of 3 is 2, sorry. Got there. So we had to show the continuous part. We have to show the differential part. Again, I did not show the work for that derivative. You should do that. If you have questions on that, feel free to talk to me about them. But you should do that work. We don't have time to go through these, so I'm going to show you the answers. So, for example, for a constant, so this is saying, let's pretend f of x is c. So it's going to be the limit as h goes to 0 of f of x plus h, which is c, minus f of x, which is c, all over h. So that's going to be 0. So the derivative of a constant is 0. This is c is some real number. A linear function. So let's suppose h of x is mx plus b. So the limit as h goes to 0, mx plus h plus b minus mx plus b all over h. You should be able to do that and figure out that you get m. So the derivative of a linear function, I'm writing as mx plus b because a lot of y'all we'll think of it as that. This one, the proof is in the book. I mean, all these proofs I believe are in the book, but it's a little bit crazy, so I'm not going to show you that, but I'm just going to write down the derivative of a power, and they do it with polynomials. There's a couple other ones, because if you have fractional exponents and stuff like that, but the rule is the same. You bring the power down, and then you do n minus 1. So for example, if you have x to the fourth, the derivative of x to the fourth is 4x cubed. And that ddx is just saying take the derivative of the function with respect to x. Constant multiple. So suppose we have a g of x is k times f of x. So you'd set up your limit as h goes to 0, g of x plus h, which would be k of x plus f of x plus h, minus k f of x all over h. You should be able to figure out that the derivative, I'm not going to have enough room, that was a terrible place to put that, the derivative of a constant function, where am I going to put this? Derivative of a constant function, constant multiple, is the same thing as a constant multiple times that derivative. You should be able to figure that out. If you have troubles, let me know. So basically, you can kind of ignore the constant and slap it on at the end. So if I put a 7 in here, it would just be, instead of 4, it would be I'll show the work. Well, I'll show you the step. 4 times 7x to the third, which obviously 4 times 7 is 28. So those are some basic derivatives. Derivative of a constant is 0. Derivative of a linear function is simply whatever the slope of that function is, which we're calling m. The power rule is where the power comes down. You subtract 1 from the power. And then the constant multiple, like a 3 or a 12 or whatever it is, ignore that number, take the derivative of the function as normal, and then put that number back in. All right, so product rule. Product rule is interesting. So basically, we want to find the derivative of f times g. So it's going to be the limit as h goes to 0 of f of x plus h, g of x plus h, no, not the minus there, minus f of x, g of x, all over h. So, I'm going to do this. I'm going to tell you where we're going. So the derivative of f times g is the derivative of f times g plus f times the derivative, I'm going to write that as dg dx, and I'm going to change that one to df dx to make it a little clearer to you. So the derivative of f times g plus f times the derivative of g. So if we want the derivative of f, we have an f of x plus h here. We want an f of x. Because if I have f of x plus h minus f of x, that will get me the derivative of f. Now if I subtract it there, I better add it here so I don't break the rules. I'm not going to run out of room. And I'm going to need that g of x plus h because I need a g of x plus h because I need the derivative of a g here. So g of x plus h and g of x are going to be friends. But I need to do that. Now look at those two pieces. Do you notice that those two pieces are identical? So I didn't really do anything. I added and subtracted two different things, but really it's the same thing. So I can write that as two different pieces now. Limit as h goes to 0. I'm going to do two steps at once. I'm going to pull the g of x plus h out, and then say times f of x plus h minus f of x all over h, and then plus the limit as h goes to 0, And in this case, I'm going to have g of x plus h minus g of x all over h. And I can pull that f of x all the way outside of the limit. So stare at that for a minute. See if you can figure out that algebra and what the heck is going on there. And then let's evaluate the limit. So the limit as h goes to 0 of g of x plus h is just g of x. I'm going to put it over here so it matches the format I have below. And then the limit of this whole big thing, that's just the derivative of f. Well, let's just call it f prime. Well, I'll mix my notations just to give you exposure to both. So f of x plus h minus f of x all over h, limit as h goes to 0 of that is just f prime. This here, likewise, is just g prime. I'm also calling it dg dx down here. And then we have f of x. So that's product rule. So the derivative of two functions being multiplied together is take the derivative of the first, multiply by the second, add the first times the derivative of the second. Now, the quotient rule is very similar. So it's going to be set up much the same way. The limit as h goes to 0, f of x plus h over g of x plus h minus f of x over g of x all over h. So here's what we're going to do. Step 1, let's get a common denominator so that everything is easy. So let's put a g of x here and a g of x here and an f of x plus h and an f of x plus h here, because then we'll have a common denominator. And see how we have f of x plus h? Let me get my little laser pointer here. F of x plus h here. Just like in product rule, I would like to subtract an f of x. But obviously if I subtract that f of x, I have to add that f of x somewhere else. And then I have a g of x there, so I need a g of x. I messed up over on the right side, that's why I'm hesitating. Right here, I wrote an f, oops, that should be a g. Sorry, I got distracted because I noticed that was wrong. G and g, there we go, that'll be better. And back to our regularly scheduled program, I subtracted f of x, g of x, let's add f of x, g of x. So that's very similar, right? Very similar step to the last one. Let's get a common denominator again, g of x plus h, g of x, g of x plus h, g of x. Notice I didn't do anything. I subtracted and added the same thing, so I didn't change a thing. So, we can do this. Look at the first part. So these two pieces, look at those. See how you have an f of x plus h and an f of x, and you have a g and a g. So, let's go ahead and take the g of x out, because it doesn't have anything to do with the h. So I can take that out of the limit. And then we have f of x plus h minus f of x over h. And down here we still have this, much like on a problem we did earlier, where that's just going to wind up down here. G of x plus h, g of x. And then similarly, over yonder, see how I have a minus though in front of my g of x plus h? I'd like that to be flipped, because I would like that to be a plus. So I want to subtract. I can take the f of x all the way out, limit as h goes to 0. G of x plus h, I'm putting that first because it was being subtracted, minus g of x. I'm subtracting that because if I minus minus, let me point at that so you can see I'm minus minus, that will give me the plus I have here. over, once again, h, and then g of x plus h, g of x. Okay, keep reading. Feel free to pause, look at this, and process this. This piece here, that's the derivative of f. So, I have the derivative of f prime. I have that g still. I'm ignoring a part right now. Shh. Don't worry. And then this part right here, that's the derivative of g. Now, look back at product rule. Did you look at it? Look at quotient rule. What do you think? Don't worry, I didn't forget this part. As h goes to 0, g of x plus h becomes g of x. G of x times g of x is g of x squared. So the derivative of a quotient is f prime g minus f g prime all over g squared. And we'll play with that. And the pink sticky says, what's an antiderivative? Well, a derivative is finding the slopey stuff, right? So an antiderivative is like the other direction. Should be thinking about that.